Okay, so covalent molecules. Let's take a look at what the word means to begin with. There are two word parts, co and valent. Co we use all the time. What does that mean? If you cooperate or coexist together. So cooperate means operate or work together. Coexist means exist together. So co means, means together. What about valent? Valent is a word, or valence is a word that we came across the other day. Outside, what? It's that outer. Where did you use valent?
Where did we use? It was in the column number of the periodic.
And what does that tell us?
The column number tells how many electrons are in the outer shell or the valence shell.
And the valence shell. That means the outer shell of electrons. Go ahead, Drew. It can hear you.
What?
It can hear you when you say stuff like that. It never misbehaves for me because I'm never mean to it. So covalent means outer shell of electrons together. And as Emily indicated just a little while ago, there's reasons for that. We're going to look at that. In this case, we have a pair of electrons being shared between atoms. So it's not that one takes an electron from the other atom. It's that, hey, I need one, you need one, let's get together and share. This is only going to be nonmetals. How do we know which ones are metals and which ones are nonmetals? Periodic table actually tells us. It's got a big divider right here. So if you look on this one, it's red. On yours, it's just bolded. That line is the divider between metals and nonmetals. Which side's which? Which side has the metals and which side has the nonmetals? Let's look at, Emily? Left side has a bunch of metals that we're familiar with. So if you just look at that, well, it's got copper and iron and nickel and aluminum. Those are all metals. So everything on this side, which is blue and the orange on mine, are metals. Even as we go down. The ones on the right side are the nonmetals that we're talking about with covalent bonding. And then there are some right in the middle that sort of along that border that sort of have the characteristics of both. And so sometimes they will bond covalently, sometimes not. But for our purposes, we're going to try and be pretty straightforward and just look at the nonmetals. These are called molecules when we've got them covalently bonded, as Courtney mentioned. If somebody says molecules and uses it in the right way, it always means that these are covalently bonded. So things like water molecules. Whoa, we know that water is covalently bonded. So examples, we've got hydrogen gas. Hydrogen is sort of an exception to that left or right because we put it over on the left because it has one valence electron, but it's really a nonmetal. It just fits there because of the one. Oxygen gas that is in our air, 21% of our air is O2. We've got carbon dioxide in the air, little bits. That's carbon and oxygen, both of those are nonmetals. Methane gas, part of natural gas, carbon and hydrogen, both of those are nonmetals. Or glucose, sugar, simple sugar. is carbon, hydrogen, and oxygen. And we'll learn some of the rules about how these go together as well. But for today, I'm mostly interested in little parts of this, not necessarily how exactly they go together. Today what we're going to talk about is why do they bond, how many bonds does an atom form, and then what do we call the molecules, how do we name them when they are formed. Okay, so let's take a look at fluorine. We're going to talk about, this is why stuff would bond. Emily already helped us with that a bit. First thing is, notice how fluorine is spelled. That's one that a lot of students get wrong on quizzes because they don't spell it right. It's UO, not OU. It's not flowering. It's fluorine. So, but and I warn you of that because if you get it and you spell it wrong, these are this spelling counts on these quizzes. So you do need to spell it right to get the points for it. So pay special attention to that one. We have two fluorine atoms that would be close to one another. And they have, how many, before we get there, find fluorine on your periodic table, over here. Second row, most of the way to the right. How many valence electrons does fluorine have? 7. We know that because it's the column number. Now, every atom wants to have a full shell because that allows it to be most stable. Fluorine and the rest of the nonmetals here are close to filling their shells. They all want to get to 8. 8 is stable. It's the most stable you can be because that's the full shell, with the exception, of course, of hydrogen that fills up with 2. But all the rest of these noble gases already have full shells, and they don't react chemically with other things because of that, because they're stable. But fluorine has 7 in its outer shell. In order to fill its outer shell, what does fluorine want? Not a trick question. It's got 7. It wants to get to 8 electrons, so what does it want?
Another electron.
Another electron. When we've got a pair of them, so here is a diagram of that. Fluorine has 9 protons, it's number 9, meaning it normally has 9 electrons as well. The first 2 go into that first shell, then you start filling up the second shell. Since it's got 7, that'd be enough to fill up these, but it's 1 short. And then here we have another identical fluorine atom, same deal, they're both 1 short. So they kind of get together and say, well, why don't we just share? They merge, they get their valence shells, their outer shells, merge them close enough together so that this electron will orbit this atom and that atom. And then this electron from the second fluorine will do the same. It will orbit both. So while neither quite fills its outer shell, both of them have enough to be full, and they'll form a bond. That bond is sharing an electron. Ooh, that was nice. So they merge, and then we could draw it this way where these two are shared between them. And now if you count the electrons around each, they actually have 10 electrons. It's kind of around each, and that makes that second shell full. And we get a fluorine molecule, which is F2, we'd write it. Okay. Do I want to go through these? No, we're not doing this just yet. We're going to do this tomorrow. Come on, Speedy. We don't care about that. We don't care about drawing either. That's our next task. Naming. Okay, here's the naming part. So for today, one part of the homework is for you to identify how many bonds will an atom form. All that means is how many more electrons does it have to gain to get up to 8, to fill its shell. But let's talk about naming covalent molecules. So let's take our old friend water. H2O. The way we write out formulas, the subscript number, which means sunken number, after a molecule tells us how many, or after an atom tells us how many atoms of that kind are in a molecule. So this H2 means we have 2 hydrogens. I don't have a number after that. How come? What does it mean not to have a number, do you think? There's one of them. It's sort of like having an X in algebra. You usually don't put 1x. The 1 is implied. Same thing here. If there's no number, it's 1. So we have 2 hydrogens and 1 oxygen. Now here's where the naming part, the challenging naming part comes in. Because this is going to have 2 names, a first name and a second name, based on the atoms here. The first name, we're going to use the regular old element, so hydrogen. But then we're going to put a prefix on it to indicate how many there are. The prefixes come from Greek. So you've seen some of these in geometry, since a lot of our geometry comes from the Greeks. If we have just 1, we would use the prefix mono. 2, prefix di, tri, tetra. Write these down. These prefixes are ones that you'll need to know for part of the naming. Okay, so that's the first name. Now, the only thing that I'll say is in this very first name, we very rarely use the prefix mono. So if there were only 1 hydrogen, we probably wouldn't say mono. We would just say hydrogen. And it implies that there's 1. But I do want you to know, because we will definitely use it for the second name. Name the second element. It gets an IDE suffix. And this is really the toughest part of it. Figuring out where to put that IDE and what to keep of the original. So I'm going to have you write this down. We're still going to use the prefixes, same as the ones you've already got for the first name. But now we get an IDE. And so you've heard these before, carbon dioxide. What else do we have? Hydrogen chloride, you might have heard. Fluoride treatment in water is similar, but it's the same naming, but different chemistry. Nitrous oxide. Okay, now there is a rule, and I want to see if I've got this rule up. So I'm going to freeze this. So
It's like nervous system. Well, I go and jump down and see.
We're going to go through in just a minute rules that you can follow to help you figure out what to put in that last part. So how do you shorten the name? How does oxygen become oxide? Rather than having to memorize quite every one at this point, you'll be able to figure out what they are. So I'm going to bring up a new page for that to get those rules, because I don't have them here. And while we are talking just about covalent molecules now, and we'll talk about another type next week, the naming stuff that we're going to use right here with the IDE versions will be the same regardless of which type we're looking at. Just as soon as this comes.
No.
If this comes up. Okay, so naming, let's say, we'll say compound second names. Okay, and I'm going to try and run down some rules that will take a little bit of practice, but should at least get you to where you can name them on your own. So the first thing is, write out normal atom name. So I'm going to use, let's use chlorine as an example. So up here, I'll just write that out, chlorine.
Chlorine's the stuff that knocks you out, right?
No, chlorine's the stuff that kills you.
Cool. Like, you know, the red one. Hey, does it smell like chlorine or?
Chloroform.
Yeah, it's cool.
I think that has chlorine in it. I forget what the molecule is.
So why do they put chlorine inside a pool?
It kills bacteria and other stuff, and if there's enough, it kills us too.
Cool.
Yeah, but and we put it even in drinking water at small amounts to make sure it kills bacteria. Now, chlorine evaporates very quickly from water, which is why if you've got a pool, you've got to keep adding stuff that produces chlorine in it to keep it germ-free. Now, for this, you want to keep everything up to the second set of vowels. In the name, and cross out the remaining. What are the vowels? A-E-I-O-U. Right, A-E-I-O-U, and Y, depending on the sound it makes.
Oh, yeah.
This is the tricky part, this step. So in chlorine, if we keep up to the second set of vowel, oops, I gotta change that in the name, and the consonants right after it. So you're kind of keeping up until the second group of vowels. Oh, no, I had it right. I'm sorry.
What?
Oh, no!
That's terrible.
I was thinking I had written the first set. Okay, so everything up to the second set of vowels. We'll practice, don't worry. So it'll become clear. And then we'll cross out the rest. I was right in the first place.
Toby. Not my time.
Okay, so let's look at chlorine. First vowel is going to be the O. Second vowel is the I. So we keep up everything up to the second set of vowels. There could be more than one vowel there, which is why I say set. But we want to keep everything up to that and cross out the rest. So that would leave us with the chlor. Right? So we go up to the second vowel, we cross it and everything following it out. Not always a second vowel. We'll do fluorine just to practice this.
This is kind of confusing, to be honest.
That's why we got to practice. That's okay. Replace the rest. So replace the crossed out portion with IDE. IDE.
I got you. Fluoride?
Right. Right? So instead of the I and E, we get IDE. So chlorine becomes chloride.
Kind of fancy.
We will practice on 2 or 3 more here. Tough ones.
Tough one.
Well, yeah, because let's look at oxygen. We'll look at fluoride, or fluorine, sorry. And we'll look at phosphorus. This rule is, I've done my best to come up with a rule that you can follow. We memorized them when I was young, but I think if we've got rules, it will help you figure out what, the how and why. So let's apply it to oxygen. Where is the second group of vowels in oxygen? Or what is?
I feel like it's kid.
Yeah. It's the E. There's an O.
O is our first vowel, right? Is there anything else what else makes a vowel sound? The Y does here. So that Y makes a vowel sound, so it's a vowel.
Oh.
So here's our first group of vowels. Here's our second. So we would cross out the second and everything else and replace it with
Oxide.
IDE, so we get oxide.
Oh.
Okay, now fluorine is the main reason why I have this listed as group of consonants.
Oh.
Because this is our first consonant, but this group sticks together. So we go to the second group of consonants.
Oh.
Yep. Group.
I.
The I. The I is our second group. We cross those out and it becomes fluoride. What about phosphorus? What do we keep? What do we throw away?
Only the Oris.
Orus, right? Because we keep this and everything up to the second group of vowels. So what does that become? Phosphide, right?
Oh yeah.
All right.
No.
Make sense?
No.
It's a little practice, but this works like almost for all but one and everything we're going to use. If you go on in chemistry, did you still need that? If you go on in chemistry, you'll learn a couple that don't quite fit that, but for the most part, they do. Okay, so let's name our friend water here. Oh, the official name. What would the first name be? Well, we use the first atom. We don't change it. So it's hydrogen, and there are two of them. So we put the prefix di in front. So it's dihydrogen.
Die.
There is one of our second, so we have to use mono. And then oxygen becomes oxide. So it could be monoxide, but for some reason in English we just mush that together. Instead of having monoxide, we have monoxide.
Oh, monoxide.
Right. So water can also be called dihydrogen monoxide.
I'm calling that now.
Wild, huh? You should. DHMO.
What's the proper?
DHMO. There is another way too, because there's no real reason hydrogen should come first here. So we could also write this OH2.
Oh.
Take a moment and name it. You can work with the person next to you. What would you call something written OH2 using these rules? What's our first name? First name is usually the easier one. Well, first name is here. How many do we have? One.
One.
What prefix do we use if there's one?
Mono.
Could use mono, but this is a first name, which also means what? We don't need to use mono, and very often we wouldn't. So instead, we would just write it out, just the first type of atom, oxygen. If there's more than one, we must use the prefix, but if there's one, we usually don't. Okay, second name, what's the prefix on it? Di, because there are two of the hydrogens. Oop,
That doesn't look right.
where's my remote? There it is.
Right.
Should probably wait until we're done. We're almost done with this. Di, and then we'd write out let's write out hydrogen, but then we'll fix it. What do we need to cross off in hydrogen? So we ignore the di part for this. Just the gen? O-gen. We got to cross off the second group of vowels and anything following it, and replace it with I.
Dihydride.
So we could also call it oxygen dihydride. We could call it monooxygen or monoxygen dihydride, but we probably wouldn't.
So the first one, you don't have to change it if it's a mono.
If there's just one, you wouldn't usually put mono. If there's only one of the second atom, you must. But if there's only one of the first, you don't have to. The order here doesn't really matter. There's no hard and fast rule about which of these goes first. This is just the normal way we'd see it, H2O. Okay, let's take a couple more practice ones before we've got homework time. CO.
Carbon.
Well, the molecule we can't just name carbon because there's an oxygen in there too. But we would name the first name carbon. We wouldn't change that carbon name and since there's one of them, we don't need the mono in front of it. But you said carbon oxide. What's wrong with that oxide though? Monoxide. Second name, we do need the prefix even if there's only one. So this is carbon monoxide, the deadly gas. Oh, I guess I got them there. We keep oxygen, remember?
Oh yeah.
So we keep up through the O and X. We throw out the Y and the rest. Okay, next one. What's our first name? Carbon again. What does S stand for? Sulfur. So what do we do to sulfur?
Carbon.
Sulfide. Good. Nitrogen, because there's only one of them.
Hydrogen.
And we're working with hydrogen. What's the prefix for 3?
Trihydride.
Trihydride. No, it's ammonia. It is nitrogen trihydride is the way we name it. That is also what we call ammonia, though. I think I got one more. Ooh. Dinitrogen. Since it's not a 1, we do have to put the prefix in the first name. Not fluoride.
What?
Tetrafluoride. Prefix is tetra for 4.
He was
Tetrafluoride.
calling out the element. So
Yeah.
he didn't
Oh,
know.
gotcha. Well, that's fine. That's fine.
So you write the whole entire word?
You would write the whole thing for this.
Okay.
And it's got to be spelled correctly. What's that? Glucose doesn't follow these rules. This is only for binary or 2-atom compounds. Okay, and I believe that's all I wanted to get through today. Let's see what's next. Property. Yeah, we'll talk about properties next tomorrow. Okay, so homework today is on the Moodle site at 7.2. It's got several that are asking how many bonds would this form, which is just saying how many more electrons does it need in order to fill up its outer shell, and then naming some like this. And we've got a good 8-9 minutes left.